Building a large ship requires a significant amount of engineering work. Even the smallest parts require a lot of time and effort to design and build. Example is a ship's propeller. The propeller must be able to survive millions of miles of travel and move the ship fast enough to get from one port to another on time. Therefore, the propeller is the most important tool on a ship. Long before the actual casting process begins, the propeller must be designed. Many variables must be considered to design the most efficient propeller possible. A poorly designed propeller can cause poor fuel efficiency, low top speed, and even reduce the life of other boat components. In this case, the propeller is made in one piece from a complex alloy involving different metals. Here's the process. Print pattern. Pitch plates are necessary in sand molding patterns to abrade the spiral surface, and the accuracy can directly affect the final quality of the blade. To determine the size of the pitch plate, we consider the pitch of the blade, the shrinkage of the casting material after casting, the thickness of the bench, and the geometric characteristics of the propeller. Mold casting now. Fountain uses a clap sand mold to mold the propeller. The face of the propeller is located below and the back side of the propeller is located above. In the sand mold, first use a triangular pitch plate to complete the corresponding cylindrical surface, and then use a scraper along the axis of the helical plate set to scratch the surface of the spiral surface obliquely. A scraper is all that is needed for an equivalent pitch bar, a radial linear pitch variable with pitch changing to add a pair of scrapers. The melted alloy is then poured into the mold. Color machine, the pie and egg beaver. Process cutting the cast gate, riser, hub both ends, and axle hole processing, inserting the hole into the keyway, scraping the axle hole, processing the blade face and leaf back for balance experiments. When processing the first two ends of the hub of the riser, gate, and other parts, cause the hub before and after the two datums, then drill along the center of the hub and make a hole in the hole slot. Drilling can be carried out on a lathe or drilling machine. Some large-scale paddles can also use homemade vertical or horizontal drilling roll. Processing will generally prepare a sample model or axes to check the processing quality. Knife processing. According to the blade measurements, draw the outline line from the excess part, then process the leaf in the back. Leaf processing is based on the foliage as a reference plane. After leaf processing with it as a reference plane, remeasure the thickness of the blade, and according to the drawing requirements, determine the thickness of the metal layer on the back of the blade. At first drill, then measure the depth of the hole. Take out the fascia-shaped curve and then eliminate excess metal coating along the blade. After almost 3 weeks of production, the propeller was finally ready to be installed on the ship. All of that work is for just one component of a large tanker. Propulsion tests. The propulsion test, the model is prepared in much the same way as for the resistance experiment and turbulent stimulation on the hull, and appendages again applied. For this test, however, the model is fitted with the propeller used in the open water test, along with an appropriate drive motor and dynamometer. During the test, the model is free to heave and pitch, as in the resistance test. Propulsion tests are performed to determine the power requirements and to supply wake and thrust deduction and other input data such as the wake field and the propeller plane for the propeller design. The ship model is then equipped with a nearly optimal propeller selected from a large stock of propellers, the so-called stock propeller. The actual optimum propeller can only be designed after the propulsion test.